This video is part of a series of tutorials. If you got here by chance or by searching YouTube to understand science, in particular chemistry, then you are on the right channel. I am a retired chemistry professor and would like to share my knowledge to all who are interested in learning chemistry. Please like, give a thumbs up, and subscribe to my channel. Hit the notification bell if you like the video so I can make more content like this. Thank you. On with the video. In this video, I will discuss stoichiometry. Stoichiometry is the science of measuring how much of one thing can be produced from a certain amount of others. By now, you're familiar with reactants and products as parts of the chemical equation. In chemical work, it's important to be able to calculate how much raw material is needed to prepare a certain quantity of products. If you haven't watched the video yet about balancing chemical equation, feel free to pause this video and watch that video first to be able to understand this topic. To be able to do mass to mole conversion or vice versa, I would have to show you how to get the molar mass from atomic masses first. The molar mass of a compound is given by the sum of the relative atomic mass. Next would be a flowchart of how you would convert atoms or molecules to mole or vice versa. And mole to mass and vice versa. .02 times 10 to the 23rd is called the Avogadro's number. Mole to atom or molecule to mole, mole to mass, mass to mole. So everything must go through moles. Looking at a reaction tells us how much of something you need to react with something else to get a product. Be sure you have a balanced reaction before you start. That's the first step. Here, the relative number of reacting and resulting molecules are indicated by the coefficients associated with the molecules. Here, the combustion of ammonia in oxygen is described by the balanced chemical equation, which can be read as a sentence. As 4 molecules of ammonia react with 3 molecules of oxygen to produce 2 molecules of nitrogen and 6 molecules of water. The arrow implies that the reaction may go to completion if the amounts of the reactants conforms to the 4:3 ratio of molecules stated. Because 1 mole of any substance is a specific number of molecules, the relative number of moles undergoing reaction are the same as the relative number of molecules. Again, the arrow applies that the reaction may go to completion if the amounts of the reactants conforms to the 4:3 ratio of moles stated. And calculating the masses would give us the mass ratio of 68 to 96 to 56 to 108, which would give 164 units on both sides of the equation. Okay, let me give you another examples here. For mole-to-mole conversions, conversion of moles of one reagent to moles of another using a ratio of the coefficient of the balanced equation. For mole-to-mass conversions, most of the time in chemistry, the amounts are given in grams instead of moles. We still go through moles and use the mole ratio, but now we also use molar mass to get to grams. For mass to mole conversions, we can also start with mass and convert to moles of product or another reactant. We use molar mass and the molar ratio to get to moles of the compound of interest. For mass to mass conversions, most often we are given a starting mass and want to find out the mass of a product we will get, or how much of another reactant we need to completely react with it. Now we must go from grams to moles, mole ratio, and back to grams of compound we are interested in. Time to practice. Feel free to pause the video if you need to. Thank you very much for watching, and I will see you in the next video.